Okay, so in this video, we're going to go over how to solve multi-step equations and equations that have variables on each side. So the last video was primarily one-step equations. You only had to really do one thing. In this video, all of these equations are multi-step, and they're going to require more than one operation. Okay, so just like last time, the goal is to get the variable by itself. So that usually means that the variable is being multiplied or divided by a number, and then there's also an addition or subtraction or something else going on. The first thing you're going to do is you're going to move the number that is not attached to the variable. So in this case, we're going to move 4. So I'm going to add 4 to both sides of my equation. Okay, and this gives me a 33. All right. Remember, we need x to be by itself. So what we're going to do is this is 11 times x. We need to do the opposite of what's being done. So if we have 11 times x, then I'm going to divide by 11 from both sides, and x is equal to 3. And this is our answer, because we can't go any further and x is by itself. Okay. Now in the second one, you have x in the numerator of a fraction. If you remember from the last video, we talked about how whenever you have a fraction, technically you have a division. So what's going on is technically we have 8 plus 7 divided by 8. Whenever you have a fraction, the first thing you're going to do is to multiply by the denominator. I'm going to use parentheses this time. Multiply by the denominator to both sides. What this does is this gets rid of the denominator, so the 8's will go away, and you're left with the numerator. So a plus 7 is equal to 5 times 8. Okay. Now we're going to simplify the right side of the equation. And I know I'm showing a lot of the in-between steps. You don't have to do all these little bitty in-between steps, but I'm showing them to you so that you can easily follow the whole process. Okay. So now we have a plus 7 equals 40. We need to get a by itself. There's still a 7 on this side, so it's being added. So I need to subtract it from both sides. A is equal to 33. Now, whenever you're doing these problems, whether they're as straightforward as these, or if they when they get more complicated, always remember you're doing one number at a time. You're starting with the numbers that are as separated from the variable as possible. So in this first case, in this first problem, it was the 4. That was the number that was most separated from the variable. In the second problem, there really wasn't a number as nicely separated as the 4 was in this first problem, but you did have a fraction. Okay? You needed to get rid of the fraction first. So we did that. Then you have the 7, which is nicely separated, and we can subtract that away. Okay, so that's the first thing. Start with the number that is most separated from the variable. The second thing, whatever operation that is being done to the number, you're always going to do the opposite. So in this first problem, it was a minus 4, so we added 4. It was 11 times x, so we divided by 11. Whatever's being done, you always do the opposite. Now, when you have variables on both sides, the number one thing you got to worry about is getting the variables together on one side of the equation. It doesn't exactly matter which side of the equation you go. My personal preference is the left side, but that's just me. If you like the right side, go for it. Okay. So when I look at this equation, I'm actually going to rewrite it so I have more room. When I look at this equation, what I'm going to do is I'm going to move the numbers that are not attached to the variable first. Okay, so I'm going to move the numbers not attached to the variable. So in this case, I'm going to move them over to here, I'll do it in blue. I'm going to move my normal numbers to the right. So that means I'm going to subtract 2 from this side, because it's a positive, It's a positive 2, so I have to subtract it from both sides of the equation. Now I have 5k is equal to 3k minus 8. And now I need to get my k's on the same side of the equation. So I'm going to go the other direction. Move my k's to the left side. Minus 3k, minus 3k, minus 8. And now I need to get k all by itself, so I'm going to divide the 2 away, because this is 2 times k. So I need to divide this from both sides, and k is equal to a negative 4. 2 things I want you to pay attention to, because at least for me, they were the bane of my existence, and sometimes still are. Number 1, don't lose your variables. Common mistake is to only subtract the 3 and then suddenly you don't have a k. Like your k vanishes somehow. Always make sure that when you move a variable from one side of the equation to the other side, that the variable goes with the number. The number and the variable are together until you divide them. The second thing, it's just kind of, I can star the whole problem, but definitely down here, make sure you don't lose your signs. So don't lose your variable, and then don't lose your sign. Those are the 2 common mistakes with this type of problem. Now, if you read the instructions before we started, you would notice this little thing called check your solution. The nice thing about math is whenever you get an answer, you can almost always plug it back in to see if you got it right. If it comes out nicely, then you know you did it right. If it doesn't, then something went horribly wrong, go back and check. So I have 2 plus 5. I'm going to plug my negative 4 in using parentheses. All right. And now I'm going to solve. If negative 4 is the appropriate answer, if that's the right answer, then we should get the number on both sides of the equal sign. So make sure you're using order of operations correctly. So I have a negative 20 right here. 12 minus 6. 2 minus 20 is a negative 18. Negative 12 minus 6 is also a negative 18. That checks out. Yep. Always check your work. Always check your work. It just catches the small math errors. You can find and save yourself so many problems if you check your work. All right. Now, when you have the more complicated problems, the first thing you're going to do, just like the order of operations states, is to get rid of your grouping symbols. Okay? Order of operation does not go away. Make sure you're doing the grouping symbols first, or in the case of fractions, the numerator and the denominator, before you start trying to move the variable around. So, in this first problem, we're going to distribute the 3 to both. 8s minus 10 is equal to 6 minus, equal to 18. 18 minus 6s. Okay. Now that we don't have any more grouping symbols, now we can move the variable to the other side of the equation and start moving things around. So I'm going to move my normal number first. And you don't have to do it like this. I'm doing it like this so you can see each of my steps. But if you want to move the variable first, that's quite all right. Okay. Now I'm going to move my variable, so plus 6s. Also, with variables like s and t, be very careful they don't turn into 5s. Okay. I'm running out of room, so I'm going to rewrite this up here. I need s to be by itself, so I'm going to divide by 14. And now I have s is equal to 2. Right. I'm going to let you go back and check. So in your notes, you're going to check and make sure that that actually works. Okay. The video is going to pause here. Again, check and make sure that 2 equals s is correct. And then I also want you to do this one down here. So you're going to check my work, and then you're going to do this problem and check this problem. Okay, here are the answers. As you can see, both check out. So s does equal 2 and n equals 1/9. On that bottom problem, don't be afraid of fractions. You know how to handle them. Just go through it and double check. If ever you doubt yourself, check for small math errors. All right, the last thing we're going to go over is special solutions. Now, there are some equations that just don't work. There are some equations that have no solution, or that they're weird, but where every number works. So in this first one, if we solve for x, just solve for x like normal. So I have 5x plus 5 is equal to 15x minus 4 minus 10x. Okay, now before I move things around, notice that you have 2 x's on one side of the equation. So I'm going to combine like terms on this side of the equation before I move things across the equation. So now I have 5x plus 5 is equal to 5x minus 4. Okay, I'm going to subtract 5 from this side. 5x is equal to 5x minus 9. And you might be able to already see it coming, but I'm just doing it the way I've been doing it so you can see the pattern. Now I'm going to subtract 5x from this side, minus 5x from that side. 0 equals -9. If you're going, Miss Stockton, 0 does not equal -9, you would be correct. This doesn't work. Now, whenever you get a situation like this, the first thing you need to do is go back and check for small math errors. Make sure you multiplied correctly. Make sure you didn't lose a sign or a variable. If you've checked your work and there are no small math errors, this is actually the answer you got, then the answer that you're left with is that there are no solutions. Okay? This means that no matter what you plug in for x, you're never going to get the right answer. Okay? So in our other problems, when we plugged in for x, we eventually got the same number on each side of the equal sign. Whenever you have a no solution, it doesn't matter what you plug in, you will never get the same number on each side of the equal sign. It just won't work. All right, so that's the no solution one. The next one are called identities, and that's down here. So let's solve first, and then I'll explain what happens. So we have 7x plus 5x minus 5, and 5 plus 12x. Okay. Again, I have two variables on one side of the equal sign, so I'm going to combine like terms first before I move things around. Okay. If you're looking at this problem and going, Miss Stockton, that is the exact same thing on both sides of the equal sign, you would again be correct. Notice we both sides of the equal sign have a -5. Both sides of the equal sign have a positive 12x. If we were to continue to move things around, to subtract the 12x from one side and subtract from the other, we would eventually get 0 equals 0. What this means is that no matter what x you plug in, no matter what number you plug in for x, you're always going to get the right answer. It's always going to work. You could plug 5 in for x and it would work. You could plug 100 in for x and it would work. You could plug negative something and it would still work. No matter what you do, no matter what number goes in here, it will always work 100% of the time. This is called an identity, and the answer is all real numbers. Or the weird looking R. Okay, either one of those work. Right. So again, these special solutions are special. They don't happen all the time. So whenever you get an answer like this, double check, go back, make sure you didn't make any small math errors. But if you're confident that there was no small math errors, and you get a situation where it just isn't true, 0 never equals -9, or you get a situation where it's always true, then go with your gut, trust yourself. It's either no solutions or all real numbers. All right, that is the last slide. I'll see you guys in class.